Hi there, I'm Scott Francis, editor of CompositesWorld, and I'm here at Westlake Epoxy talking to Amitabh Bansal, segment leader for composites. We're talking about high rate production for aerospace. Amitabh, tell us some about some of your solutions.
Well, thanks for talking to us, first of all, Scott. Happy to do that. So really, this story started with automotive about 15 years ago, where build rates, quality, and efficiency were key. The automotive OEMs like BMW, Volvo, they're using our resin systems to make parts. Over the last 5 to 6 years, we've seen a transition of that technology from automotive going into aerospace. And aerospace, they want to make the planes lighter, they want to make them more efficient. There is an ESG component to that as well. And we see larger and larger adoption of composites overall, right? So as an example, right, things that used to take hours to lay up, build, pull out of the mold, now can be done in less than half an hour. Yeah? And then there are technologies to automate those completely that goes towards efficiency, less wastage, and high rates of production.
Cool. So tell us about some of your approaches to this.
So it really depends on the part complexity and how big the part is, how thick the part is structural, is semi-structural. But largely, we break down our approach into two things: is efficiency to make things, and sustainability. Yeah. And sustainability is a topic that comes up quite a lot. It's primarily driven by product carbon footprint reduction. So we have not just resins that are either bio-derived or made using renewable energy. We are EcoVadis certified. We are EcoVadis full. That means top 5% of the companies who are certified. But then efficiency means less consumption of power, less consumption of material, less wastage overall, and that also goes towards the carbon footprint of the end user and the producer of the part. Yeah? What you're looking at here is as an airplane gutter for Airbus that was made by Dyer. Yeah? Using traditional pre-preg technology, this part to lay it up, mold it, takes hours. Yeah? Using a vacuum-assisted RTM technology, this is a 15-minute cycle from layup to part extraction, and it's a production-ready part at that point. So you can do that using epoxies. You can also do that using phenolic resins. And both of these are made using proprietary technology that Westlake has come up with. So what you have here, Scott, is a turnkey solution provided by one of our partners, our automators, Coriolis. They're based out of France. So they've come up with this automated fiber placement, which is then secured with a felting technology, right, to kind of make it stiff so that once you place the fibers, they don't move. In this process, some of our binders have been used, which is then formed into a preform, right? So again, it's stiff, so that you're not losing any of the translation of the carbon fiber properties to the final part. This is then water jetted out into a preform like this. And this is what goes into your mold. It gets injected with the resin, and out pops a part like this. Yeah? And the key here is that each step in this process is taking 3 to 4 minutes. So if you combine the whole cycle process from end to end, you're coming up with a 15-20 minute part. Yeah? And using traditional either hand layup or other kinds of technologies, this would have taken a couple of hours to build. So as you can see on that part, it's got fine angles, and using computer simulations, you can optimize how to lay the tape or the fiber, and this can also predict what the end properties, mechanical properties of the part are going to be. So again, you kind of see that theme. All of this started with automotive OEMs demanding that, and this is what is being now adopted more and more in the aerospace industry.
Well, Amitabh, thank you so much for taking time to talk to us. This has been great.
Scott, thank you so much for stopping by.
Thanks.
I appreciate it.